In this video, I'm going to be introducing the concept of a power series. So what is a power series? Well, let's just back up a little bit and review some things that we already know. First of all, we know what a sequence is. And a sequence, a sub n, would be something like a sub 1, comma, a sub 2, comma, a sub 3, dot, dot, dot. It goes on infinitely far. These are the terms of the sequence, and a sequence is just a list of numbers. Then we know what a series is. And a series is when we sum up from n equals 1 to some number, usually infinity, all the terms of a sequence. So that would be a sub 1 plus a sub 2 plus a sub 3, dot, dot, dot. So this would be an infinite series. A series can be finite or infinite. Finally, this leads us to our new concept of a power series. And a power series would look something like this. We're going to have a variable x minus some number c raised to the n power. So n is the exponent or the power of x. That's why it's called a power series. And so the terms of this would look something like this. A sub 1 times x minus c to the first power, of course. A sub 2 times x minus c squared plus a sub 3 x minus c cubed. Now, what is this c value that we have here? Well, c is referred to as the center of the series. C equals the center of the series. Think of the center as the anchor. This is where the series is anchored down to something. And of course, x is just a variable. X equals a variable, an unknown quantity. And so those are the new aspects of a series. This part right here is what makes it a power series. So let's take a look at a couple of examples of power series. First of all, let's do something like this. Something simple like n over 2 to the n times x to the n. All right, and so the terms of this sequence, when n is equal to 1, we're going to have 1 over 2 times x to the first. Then when x is equal to 2, we're going to have 2 over 4 x squared. When n is equal to 3, we will have 3 over 2 cubed is 8 times x cubed, on and on and on. All right, in this particular series, c, the center, is equal to 0. That's why we have x to the n is really x minus 0 to the n. And of course, x is our variable. One other important thing here is a sub n is called the coefficient of the power series. The coefficient of the power series. Now, if you look at the power series we just did, you can see why. So a sub n in this particular example was this. And that gave us the coefficients of the variables. All right? And so that's why a sub n is referred to as the coefficient, because it gives us the coefficients of each one of the terms of the series. Let's do another example. So let's say we have the summation from n equals 0. Now, sometimes power series are going to start at n equals 0, so you have to be careful of that. And let's say we have n squared plus 1 over n factorial times x minus 1 to the n. So the terms of this sequence are going to be, when n is equal to 0, we will have 0 squared is 0 plus 1 is 1 over 0 factorial is 1. And then we're going to have x minus 1 to the 0 power. Anything to the 0 power is just 1, so this all just becomes 1. Plus, now when n is equal to 1, we're going to have 1 squared is 1 plus 1 is 2. And 1 factorial is 1. And then we have x minus 1 to the first power. And then the third term, when n is equal, this is when n is equal to 0, n is equal to 1, and now when n is equal to 2, we will have 2 squared is 4 plus 1 is 5 over 2 factorial, which is just 2, times x minus 1 squared, on and on and on. And of course, we would clean this up a little bit. We would have 1 plus 2 times x minus 1 plus 5 halves times x minus 2 squared, dot, dot, dot. And so in this particular case, a sub n, which is n squared plus 1 over n factorial, is the coefficient. And again, you can see because this, whoops, this gives us all of the coefficients. And you can also see in this that the center C is equal to 1. All right, so that is what a power series is. It's pretty easy to recognize a power series because it's going to have some power of x. The next thing that we want to take a look at is, when does a power series converge? So we want to take a look at convergence. Convergence of a power series. And so the question that we want to ask is, for what values of x? For what values of x will a power series converge? Question mark. And as it turns out, there are 3 possibilities, and I will discuss each of those here. There are 3 possibilities. Number 1 is that the power series will converge only at C. Converge only at C. So if we take a look at a number line, and on that number line, let's just put C right there in the middle. Well, if the power series only converges at C, it would converge at one single point, C. And so we would say that it converges at C equals whatever it is. The second possibility is that the power series will converge over an interval. Converge over an interval C plus or minus A. And it might be a closed interval or an open interval, but it's going to be some interval centered at C. So once again, if we look at a number line and we have C here in the middle, and then we have A over here and negative A over here, and it converges from C to A and to negative A. Now, I'm not putting normal interval notation because we don't know if it converges at the endpoints or not. It always is going to converge. We could put like rounded brackets here, I guess. But it might include the endpoints not, but that's a discussion for a further lesson. So we would say that it converges over C plus or minus A, or using interval notation, we would say from negative A to positive A. And if we do include the endpoints, it would be negative A to positive A with the squared bracket. So it's an interval. The third possibility is that it converges everywhere. Converges for all values of x. So on a number line, once again, we have C, but it converges all the way out to positive infinity and all the way out to negative infinity in both directions everywhere. So we would say that it converges from negative infinity to positive infinity everywhere. So those are the three different possibilities. Once again, to summarize, number one, converges at C. Number two, converges at an interval C plus or minus A. And three, converges everywhere from negative infinity to positive infinity. One thing that you will notice here, this is very important, is that in all three cases, they all converge at C. So that means all power series will always converge at C. They may not converge anywhere else, but they always converge at C. So power series will always converge at C. Will always converge at C. That may be the only point they converge at, but they may converge at more points. All right, in the next video lesson that I do, we're going to actually use the ratio test to determine whether a power series converges or not.